Alright, here we are with EI Lesson 6, Scientific Notation. We're changing off of the exponential situations that we were talking about last time and doing a little something different this time. So make sure to take some notes on this first little bit of this video. Our objective is to use numbers expressed in the form of a single digit times an integer power of 10 to estimate super large or super small quantities. So here's the rule. To express a positive number in scientific notation, you can write it as the product of a power of 10 and a number between 1 and 10. For instance, 4,800 is 4.8 times 1,000. But we want to write it as a power of 10. So 1,000 is 10 with 3 zeros. Or rather, 1 with 3 zeros is a better way to think of that. So you can think of this exponent as how many zeros it has. 4.8, move the decimal over how many times? 3 times to the right. Okay, we'll do a couple other examples of this in the practice right here. 1, 2, 3 for 3. First one, are the following in scientific notation? If not, we'll state the reason. So, scientific notation, once again, we want a single digit times an integer power of 10. So here's a single digit, 3. The decimals, it doesn't matter how many there are, times an integer power, integer 10 squared, of 10. Yes, ching. Man, my check marks are pretty. Oh, that's beautiful. All right. People spend approximately 50 times 10 to the negative 1 minutes on Facebook each month. Is this a single digit? No. Nope, not a single digit. A golf ball has a diameter of, here's a single digit with some decimals, times 10 to the 0 inches. Yeah, technically that's in scientific notation. 10 to the 0 is a silly way to write 1, but yes, that's in scientific notation. Ching. Not as good as my last check mark, honestly. It would take a person approximately 0.116 plus 10 to the third hours. Okay, we have two problems with this. One, scientific notation always has a single-digit integer. I don't even think it says that up here. It should. So 0 is not okay for scientific notation. And this should not be plus. If it's scientific notation, we need to have multiplication. So not scientific notation. All right, let's write some of these in scientific notation. You'll have your chance to do some practice in this problem set down here. I'll do these examples for you, but I do suggest that if you are watching this video as a lesson, that you stop right now and try these on your own. All right, hopefully you have a chance to do these on your own. I will go through them. Scientific notation 567.8. I need to make it a single digit, so I'm going to move the decimal twice. And by moving the decimal twice to the left, 5.678, this is times 10 to the negative, moving the decimal left, negative 2. I moved it left twice. Okay, this one I need to move the decimal right twice, so we'll do the same thing, 2.46 times 10 to the positive 2, because I moved the decimal right twice. This one I need to move the decimal 1, 2, 3 to the left. So this is 9.48332 times 10 to the negative 3. Likewise, 2 to the right here, so we have 5.623 times 10 to the second. Okay, now writing them in standard form, this is just without the scientific notation powers of 10. We're going to move the decimal how many times? To the right by 5. So this is 8, 1, 2, 3, 4, 5. 5 times to the right. Put a nice little comma in there for formatting. How many times am I going to move this decimal to the left? Well, a lot. 5 times, in fact. So we have 1, 2, 3, 4, 5. Like that. Let's make sure I did that right. It started here. We're going 1, 2, 3, 4, 5 times to the left. Yep. Just like that. All right. And here we have 3 times to the right. So this is 5, 1, 2, 3. 2 times to the left. So we have 1, 2. Put our 0 here just to make that good. I will not do these ones. I want you to do those on your own. I'm not even going to do that on the video. I will, however, mention how to do some of these because these are difficult. Please try them on your own before you watch this video, but I will go through the solutions right now after a brief pause where you'll pause the video and do them by yourself. Okay. The approximate distance to the sun is 93 billion miles. That's true. And the wavelength of ultraviolet light is really teeny tiny. What is that? 10, 100,000, 10,000, 100,000, 35 millionths of a centimeter. It's pretty small. Write both numbers in scientific notation. So remember 1 decimal, 9, 1, 2, 3, 4, 5, 6, 7. 10 to the 7th. Let's make sure I did that right. 1, 2, 3, 4, 5, 6, 7. Yep. All these zeros are actually unnecessary, so we'll go ahead and erase those, and we'll kind of move this. Oops, wrong button there. Where is my... Huh, I don't have my select tool. That's strange. Anyway, we'll move that over here, just like that. Okay. Writing these both in standard notation, no big deal, kind of like the same as the last one. 7.10 to the 5, excuse me. 1, 2, 3, 4, 5. That's how I count. And we also use units. This is in miles. This is in pounds. Okay, now let's do the negative ones. Ultraviolet is 0.000035 centimeters, 35 millionths of a centimeter. We're going to take this and the decimal move 1, 2, 3, 4, 5 times. This is going to be 3.5 times 10 to the negative 5th centimeters. Likewise, this guy, we need to move the decimal to the left by 4. So we're going to add actually 3 zeros after we move that decimal one time. 1, 2, 3, 4. And that is in pounds. For the to the sun, make sure we get our units correct. And this is centimeters for the ultraviolet light. This is for the jet weight. And this is for a spider weight. Well, they're not very heavy, are they? Common house spider. What is a common house spider? All right, the rest of these are the same. We're just going to take this and go so that the decimal's right here. That means we need 1, 2, plus 3 times 3, 9, so 11. And for this one, the same thing. We're going to count this out. How many we need to go? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going in the opposite direction. Let's make sure that we use the correct units. This is 2.5 times 10 to the negative 9 meters. This is in meters as well. You can see why scientific notation is a little bit easier to write down, especially when your numbers are exceptionally large, as if the size of an atom of gold. I don't know if this is actually true. I feel like an atom's slightly smaller than that. But anyway, we've done lesson 6. I'll see you in lesson 7.